Hi, I'm Professor Lim, and I want to talk to you about 5 terms you need to know in thermodynamics. The 5 terms is thermal energy, heat, conductivity, temperature, and specific heat, but I like to call it thermal mass. Let's talk with the first 2 terms. Thermal energy and heat are sometimes used interchangeably, but they're not the same. Say I have a whole bunch of thermal energy, which I will represent with bottle caps. So I got a handful of thermal energy right now, and I put it into an object. In this case, the object will be a jar. Now this jar has thermal energy, but that's not the same as heat. Heat is the transfer of thermal energy. So if, as I'm putting the thermal energy into the jar, I'm doing that through heat. There you go. Next is conductivity. Imagine that this jar is not wide open like this, but has a little bit of tape over it. So now it's a little harder for bottle caps, or in this case, our thermal energy, to exit or enter this jar. If I were to pour these thermal energy bits out, some of it will get stuck and it will be harder and naturally a slower process for all of the bottle caps, or sorry, thermal energy to exit the jar. That means that the jar has less conductivity. By taking off this tape, or by improving the area of the opening of the jar, I can effectively increase the conductivity of the jar. Next is temperature. Now, imagine I have the same amount of thermal energy that I talked about before. Let's add a little bit more just so we can see these the effects here. So I have a lot of thermal energy. I'm going to put all that into this jar. And as you can see, the thermal energy, actually, let me put more in. As you can see, the thermal energy has made it up to where the jar's about 75% filled. That's in a way indication of temperature. Because I put in this much thermal energy indicated by bottle caps, the temperature of this jar raised this much. Now imagine I have another jar that is of bigger girth. So not necessarily that it's taller, but it is wider on the base. I put the same amount of thermal energy into this bigger jar. As you can see, the level of the jar, or the level that the bottle caps take up in the jar, is lower than that of the smaller girth bottle. So therefore, the temperature rises less in this type of jar than it does in this type of jar. This is what we would call an issue of specific heat. This jar, having a smaller girth, has less specific heat than this jar having a wider girth. Specific heat is how much thermal energy you need to put into an object in order to raise its temperature. An object with a high specific heat will raise its temperature less per every unit of joule of thermal energy put into it. An object with a low specific heat will rise a lot in temperature with the same 1 joule of thermal energy. So if you have, we'll say this is like 40 joules represented by 40 bottle caps. You put it into a bottle with a smaller girth or a lower specific heat, this temperature is going to rise a lot higher. Excuse me, a lot higher. So I just indicated to you, or I just taught what the difference between thermal energy is, what heat is, which is simply a process of thermal energy transfer, conductivity, the ease of thermal energy transfer, temperature, the effects of thermal energy on an object, and specific heat, the girth of the bottle, or how difficult it is for thermal energy to raise its temperature. I hope this was clear enough, and if not, you can always contact me through my email, or we can arrange an office hour. Thank you very much for listening.